trig review, we're just going to look at a couple of quick, sort of more real life type of questions. But really, it's doing exactly the same thing. We just need to find some right angle triangles in our diagram. So here we have a roof on top of a house. Determine the length of the roofing beam required to support a roof of pitch 16 degrees as shown alongside. So the pitch of a roof is just the slope of it, how much it's sloping there. So we need, there is a beam that needs to support this roof. So that beam is going to have to go all the way down the middle there. So we're going to have, hopefully it will be a bit straighter than that to help support the roof. And it would make sense that that would need to be a right angle. So we need to find the length of that. So let's call that x. Here we have a right angle triangle. We have an angle. We have a side we're trying to find and a side that we know. If we look, the side that we know is opposite the right angle. So that's our hypotenuse. And then the x is opposite the 16. So we have our opposite side. If we write out our SOHCAHTOA just quickly, just so we can see which one is going to be the trig ratio we need. We have opposite, we need opposite, we have hypotenuse, so it's the first part, the SOH. So that means it's sine of the angle, so sine 16 degrees. The O is first, so opposite must go first, so in this case x over the hypotenuse, which is 9.4. I need to get rid of that 9.4, just doing some simple equation work. It's x divided by 9.4, so I multiply both sides by 9.4, so I have 9.4 times sine 16. And then we just need to grab our calculators. So I'll get my calculator up. Let's move it out of the way. Let's clear our screen a bit. So 9.4 sine 16, enter. And again, 3 significant figures, 1, 2, 3. The next digit is 0, so we don't round up, chop it off. So 2.59. So our beam needs to be approximately 2.59. Don't forget the units, meters. There you go, pretty simple. Let's try one other one. So here we need to find the length of BC. So here is BC, but if we look at that triangle that has the side BC in it, so that's what we're trying to find. This is the right angle triangle here. We don't actually know a lot about that triangle. All we know is one side. We don't know any of the angles. Not so useful. So we need to have a look at what we can find then. We might need to find something else first. If we look at triangle ABD, we have a little bit more information here which may help us. So we're looking at this green triangle first. Let's have a look. We have an angle, we have a side. We're eventually going to need to find BC. So seeing as the side BD is common to both of the triangles, the green one and the yellow one, might be a good idea to find the length of that, because then we'll know two sides and then we have to find the third side. So let's call BD, we'll call it X. So what I'm trying to find is opposite the angle. Let's get a different color. So this is opposite. This is next to the angle, so that's the adjacent. So let's quickly write out SOHCAHTOA. So I have the adjacent. I need to find the opposite, so it's TOA, so it must be tan. So what we can say is that tan 40 is equal to opposite, which is x, over adjacent, which is 4. X equals, multiply both sides by 4, so x equals tan of 40 degrees. Now I'm actually going to keep that exact because if I put that into my calculator, I'm going to get a big long decimal. So I'm going to keep it like that for the minute. And then, now I know I can put this in the calculator, get an answer. So now I have this side, I have this side, I need to find this side. So think about what else you know about right angled triangles. If you know two sides, if I call this y, if you know two sides and you need to find a third side, we can use our good old friend Pythagoras. So we'll need to remember that c squared equals a squared plus b squared. Now what's important here is the side that is your hypotenuse. C is always a hypotenuse. So in this case, the 11 centimeters is our C. So we'll have 11 squared equals. The other two sides are your A and B. It doesn't matter which one's A, which one's B. We know something for X. So it would be all of that, 4 tan 40, all squared, plus our third side squared, which we called y squared. So just rearranging that because we want y to be the subject. We're going to have, I know 11 squared is 121, minus that big mess there, 4 tan 40, all squared. I'm still not going to pick up the calculator. I'm going to try and use it in the very last step. If I have y squared, I want y by itself, so I do the inverse operation. I take the square root. Now you must take the square root of everything, remember. Whoops, I've just realized I missed out the 4 there. So you must take the square root of all of that that's on the right hand side there. And this must all be squared though first. Do not forget that. So when you're putting it into your calculator, put it in exactly as you have written it. Then you are not going to make any little silly calculator mistakes. So let's again get this out of the way and put it in as you've written it. So square root 121 minus bracket 4 tan 40 close bracket squared. Oops, I've just realized what's going to happen there because it closed the bracket on the, let's delete that. And we need to go, let's delete it. There we go. We need another closed bracket. Be careful with that. And then that is squared. And now you should be good. Let's get an answer. So again, 3 significant figures, 1, 2, 3. Oops, next one is bigger than 5, so we round up, so it's 10.5. 10.5 centimeters approximately. So BC is 10.5 centimeters. And remember, we knew it was going to be less than 11 because it's a right angled triangle. Your hypotenuse is the longer side, so it has to be less than that. Yeah, there you go. Hopefully that's helped. Good luck. Bye.